Hi IT lovers of my classes, welcome to Easy Machine Learning number 2 with Python on Google Colab. Of course, again, I invite you to watch my previous Python and machine learning tutorials. Last week, we started another project where we wanted to filter if an expression is an important math formula or a non-important text using the Regex module, which allows us to define patterns that describe sets of strings. We tested our filter method with some examples, two already, with the Pythagorean theorem and with a regular expression. Today we want to test it again, but with the Hooke's physic principle and with God's existence equation. Thank God again, I'm about to tell you the same thing in German and French. Hallo IT-Leute, willkommen zum einfachen Machine Learning Nummer 2.1 mit Python auf Google Colab. Natürlich lade ich Sie auch wieder ein, sich meine vorherigen Python und Machine Learning Tutorials anzusehen. Letzte Woche haben wir ein anderes Projekt angefangen. Wir haben gefiltert, ob ein Ausdruck eine wichtige mathematische Formel oder ein unwichtiger Text ist. Wir haben das Regex-Modul verwendet. Mit dem konnten wir ein Muster definieren, das Sätze von Zeichenfolgen beschreibt. Wir konnten diese Muster dann verwenden, um Text- und Formeldaten zu suchen, abzugleichen und zu bearbeiten. Unsere Filtermethode haben wir schon mit 2 Beispielen getestet, mit dem Satz des Pythagoras und mit einem regulären Ausdruck. Heute wollen wir mit dem physischen Prinzip von Hooke testen und auch mit diesem Formulas über Gottes Existenz. Ok, je sage Ihnen wieder das Gleiche auf Französisch. Alors, shalom à tous ceux qui apprécient mes cours de IT en ligne. Bienvenue chez Initiation Machine Learning Facile, numéro 2.1 avec Python sur Colab. Non, ça va être numéro 2.2 en fait, sur Google Colab. Bien entendu, je vous invite à regarder également mes tutoriels de Python et Machine Learning précédents. La semaine dernière, nous avons commencé un autre projet où nous avons filtré si une expression est une formule mathématique importante ou un texte non important en utilisant le module Regex qui nous permet de définir des modèles qui décrivent des ensembles de chaînes de caractères. Nous avons testé notre méthode de filtrage avec 2 exemples déjà, avec le théorème de Pythagore et avec une expression régulière. Aujourd'hui, nous voulons le tester avec un principe physique de Hooke et aussi avec une équation dont je vous ai parlé la semaine dernière qui prouve, soi-disant, l'existence de Dieu. En tout cas, avec ou sans équation, moi je sais que Dieu existe. Amen. Et grâce à lui, je suis trilingue, même plus d'ailleurs. Et voilà, je vous ai dit donc la même chose en anglais et en allemand. Maintenant, je vais vous dire la même chose en langage de programmation aussi. Parce que il faut apprendre ça, parce que avec ces robots qui arrivent en force, ça risque d'être... on va dire, ça risque de devenir chaud patate si on les maîtrise pas. Okay, this is where we stopped last time. Let me scroll down again. So we have tried with these two, first with E equal mc squared 2, and then we have tried with a regular expression. For instance, what's for dinner tonight was classified as non-important text. And when I go back and I comment this part and comment the top, we can just see again the difference. And our Pythagorean theorem is classified as an important formula. So our filter method is working with Regex. Okay, now let's try with Hooke's law. So we are going to keep pretty much the same. I'm not going to write the Hooke's law here. Actually, I could, here by the important formulas. But because we already have this one, the Pythagorean theorem, it's going to be like, easy for the model to predict what type of string it is. Okay, I'm just going to remove this both. You see, test with new data. I remove the new data of E equal MC squared 2 and the new data of what's for dinner, and I'm going to insert the Hooke's formula. Let's just type here Hooke. We're gonna get here F equal kx. So now let's test it and see what's gonna show up. So we just run and we see Hooke's law F equal kx is classified as an important formula. Okay, now the output is good. It is classified as an important formula, but now we want to know what it is. What is this Hooke's law F equal kx? Okay, here the F is the force applied to the spring in newtons, and K is the spring constant, also called the force constant or stiffness coefficient of the spring in newtons per meter. And X is the displacement of the spring from its equilibrium position in meters. And let's say in simple terms, Hooke's law tells us that the force exerted by a spring is directly proportional to how far the spring is stretched or compressed from its natural resting length. And the thing is that when I say spring here, it's not the season. Here in in the context of Hooke's law, a spring refers to a physical object typically made of metal or other elastic material that can stretch or compress when a force is applied to it and return to its original shape when the force is removed. It's a mathematical device used in various applications such as suspension system, shock absorbers, and even in everyday objects like retractable pens, door hinges, and also mattresses, ballpoint pens, toys, trampolines, car suspension system, and so on and so on. Okay, we're good with Hooke's law. So we didn't have to change anything here. We kept the math regex of the Pythagorean theorem. And even here, we didn't have to change anything. But now I want to come to this new data, the GodExistEquation data. Because we already have tried with 3 examples, this is going to be our last example with this beautiful GodExistEquation. And for this, I'm going to remove everything here at this part of our file, important formulas. This time I'm going to replace the Pythagorean theorem with this equation. Okay, I type it. It's 1, 1, 1, 1, 1, 1. It's 9 times 1. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're gonna x here, x, and again 9 times 1. It's gonna be equal 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go backwards. Now 9. and then 8, 7, 6, 5, 4, 3, 2, 1. We're going to get a comma, and we move on with, let me first finish to type it. As I said, exist God, and here we're going to get equal to, this is what we want. Let me put it here lowercase, and it's by John Mass, and I'm going to call it theorem 2, theorem. And then we're going to get that one, this part, and stick it in the back again, Control C, and Control V. I have to just remove the quotations here. I just leave the one in the back, so we have a whole string, and then we move on. And the integration by parts is going to be looking like this. I hope you remember what I told you about this integration by parts last week. Okay, now that we have typed this equation, let me tell you about it. Look, I found it on the internet, and it is by somebody named John Mass, as you can see here, by John Mass, Jonmaas. This is what he pretends, that this is an equation which confirms that God truly exists. As I said before, with or without equation, I know that God is real. God does really exist. But mathematically, this equation is supposed to prove that. So I don't know what you think about it. I thought it's, it just looks very simple. It's awesome. Well, this is 9 times 1 multiplied with 9 times 1 gives you 1, 2, 3, 4, 5, 6, 7, 8, 9, and then backwards the same thing. That's very interesting. Okay, let's test this equation here by our new data. So we take it and we copy here inside. Yes, I think it's really well, I don't know about you, but I can see a real beauty and symmetry in that simple formula or mathematical equation proving the existence of God. I really love it. Okay, so let's see if our model is going to predict the same thing, if it is an important formula as I see it, or if it is a non-important text. Okay, let's see. Let's run. We run. Okay. This formula, yes, it's classified as an important formula. So we are educating the AI, the robot. Okay, yes, this is, it's working. So we didn't have to change anything by the math regex up here, but we had to modify here, remove the theorem of Pythagor to get our God's existence equation, and it is working. So this is what it is to work with regex. That's enough for today. I hope you liked it, and the rest is coming next if God's willing. Thank you for watching. Bye bye. God bless.